Today on How It's Made. Wind generators, putting a spin on renewable energy. PVC gloves, giving laborers a helping hand. Thermoformed glass, art that's fragile but functional. And fire trucks, we're pumped to show you how they make them. Wind generators harness the power of the wind to produce electricity. As the turbine's blades revolve, they drive a rotor that generates power. This can charge a set of batteries or even feed a transmission grid. Wind power is a renewable energy source that doesn't pollute. This type of wind generator is a recreational model, designed to power a boat or cottage with up to 500 watts of electricity. To make the propeller, they lay a template on a plank of western cedar, a rot-resistant wood that's flexible and durable, yet lightweight enough for the slightest breeze to set it spinning. After tracing, they drill a hole at each end and in the middle. Then remove the template and do a rough cut using a bandsaw. Then they put the template back, using those holes they drilled to align and secure it in place. Using a router this time, they do a precision cut. The plank of wood now has the contour of a propeller. The next step is to form the profile. To do that, they bolt the wood onto the right side of a specially designed device called a propeller carving machine. On the left side is a model propeller. After adjusting the model to the proper angle, they start to cut. As the machine's roller runs over the model, it guides a shaper to carve the wood exactly like the model. It takes about 8 passes to get the propeller's profile just right. You can see the profile well once they've marked and cut off the excess on the ends. One side is flat, while the other is curved, like an airplane's wing. Now they widen the hole in the middle of the propeller and sand off the ridges left by the carving using a low-pressure inflatable drum sander, the only type flexible enough to really get into the curves. Next, they check the balancing. Watch how a mere penny can throw off this perfect equilibrium. Finally, a coat of waterproof epoxy paint, the kind used on the hulls of boats. Now they assemble the alternator, the component that generates electricity when the propeller spins. They wrap insulation around what's called the proportional electronic regulator and install it, along with wiring, into the alternator's casing. This regulator controls the electrical charge and current. The propeller spins this rotor shaft, creating an electrical charge that sends a current from the alternator to the batteries. Once the casing's bolted shut, they mount a cooling fan on the shaft's protruding axle. This fan will expel the heat all that spinning generates. Next, they assemble the parts that make up what's called the lolly shaft, the axis on which the propeller sits. This axis enables the propeller to pivot toward the direction of the wind without twisting the wires that run to the batteries. Finally, they connect the wires from the lolly shaft to the alternator. This rubber cover protects a connection from the elements. Now they assemble what's called the propeller governor, a key component that prevents the propeller from overspinning and breaking down in high winds. When the propeller spins too fast, the centrifugal force pulls on these springs. This activates the braking flaps, generating drag to slow the propeller down. Again, precision balancing is critical, otherwise you'll have a damaging vibration. After applying the manufacturer's decal, They mount the propeller's rudder onto the back end of the wind generator's frame. On the other end goes the alternator, followed by the propeller and propeller governor, both painted black to protect the waterproof coating underneath from the sun's damaging UV rays. Polyvinyl chloride, commonly known as PVC, is a durable material similar to plastic. PVC gloves are waterproof, even chemical-proof. All kinds of laborers wear them, from commercial fishermen to oil refinery workers. PVC gloves are comfortably flexible, yet sturdy. Production begins at the cutting station with stacked sheets of cotton flannel. Using a hydraulic cutting machine and a series of dies, workers slice through some 20 layers in one fell swoop, cutting out the pieces required to make cotton gloves. Those gloves will either be sold as is or used as linings for PVC gloves. The next step is to sew the pieces together. It takes a speedy seamstress just 30 seconds per hand. Next, they sew on a wrist made of a stretchy cotton and lycra knit. This seamstress works the wristing machine so quickly, we had to ask her to slow down so that we could actually see what she's doing. Throughout the sewing process, these cotton gloves have been inside out. This next machine turns them right side in, transferring them onto a heated hand form. The machine then presses each glove onto the form. The gloves drop down to a conveyor belt below. It transports them to a worker who inspects them and pairs them up left and right. Elsewhere in the factory, meanwhile, workers prepare the PVC solution. The recipe varies according to the glove model, but generally consists of coloring and 5 to 8 different chemicals. They add an antibacterial, antifungal solution to combat odor from hand perspiration. To apply the PVC, workers slip a metal form into the thumb of each lining, then put the lining onto a thumbless hand form. If the hand and thumb forms were one piece, it would be difficult to remove the stiff PVC glove afterward without tearing. The linings go through what's called the singer, a propane flame that burns off any dust or loose threads. Then it's into the PVC bath. The basin of liquid PVC moves upward, coating the liners. As the basin descends, the excess drips off. Then the gloves go for a spin under infrared lamps for 45 seconds. The spinning spreads the PVC uniformly so that it doesn't accumulate on the tips of the fingers, forming clumps. The heat ensures it dries evenly. After a second coat, the gloves pass through a propane-fired furnace for about 20 minutes at 190 degrees Celsius, then through a cooling chamber for 5 minutes. For glove models with extra strong grip, They blow PVC chips onto the first coat of PVC while it's still wet. When the gloves go through the furnace, the heat embeds the chips. After cooling, the gloves are dried and cured and ready to handle a hard day's work. Decorative glass objects can be blown or thermoformed, two very different glass-making techniques. In glass blowing, the artisan shapes hot glass by rolling it and blowing air into it. Thermoforming is more of a molding process, better suited for making flat objects. When you look at these magnificent pieces, it's hard to believe they begin as run-of-the-mill window glass. It comes in ready-made panels in thicknesses ranging from 3 to 10 millimeters. The first step is to measure the overall dimensions of the glass panel, then divide it into pieces, each slightly larger than the object it will become. They'll turn this panel into large decorative plates, so they divide it into 3 squares, each about 35 centimeters in diameter. They place each square over a paper pattern. Using a glass cutter, they score the shape of the plate. Then they apply pressure with a rubber mallet to separate the glass along the score line. They cut away the excess, breaking it off with a few gentle taps. Now they position the plate-shaped glass over a drawing and begin the artwork. First, tracing the outline. Now they embellish the design and fill in the details. They use enamel paints specifically designed for painting on glass. Once the brushwork's done, they use a paint gun to apply the background colors and shading. The glass has been cut and decorated, but it's still perfectly flat. So the final step is to mold it using extreme heat, hence the term thermoformed. The mold they use is made of fireproof materials designed to withstand high temperatures inside the oven, known as a kiln. They carefully lay the glass over the mold. They mold several different pieces at the same time. In the intense heat of the kiln, the glass will melt and take on the exact shape of the mold, right down to the most intricate textural detail. These small pieces of glass will become the paint pots on this glass replica of an artist's palette. It takes an hour and a half for the kiln temperature to climb to a scorching 843 degrees Celsius. At peak temperature, they open up briefly to make sure that everything is progressing well. The glass at this phase should be the consistency of maple taffy and glowing bright red. If it is, they can close the kiln and begin the cooling phase. 6 hours later, the glass pieces have hardened into the shape and texture of their respective molds. These plates and spoon rests and other pieces are cool enough now to come out of the kiln. The beauty of thermoformed glass lies in the striking combination of transparency and vibrant color. Add to that the endless shape possibilities, and you've got truly functional art. There are different types of fire trucks. Pumpers hook up to fire hydrants, boost the pressure, then shoot the water out through hoses. Ladder trucks elevate firefighters on either a ladder or a platform. Rescue trucks have tools to cut through metal and clear obstructions. Early firefighters couldn't do much more than pass buckets of water from man to man. The 1720s saw the arrival of wagons carrying water tanks and hand pumps. Those newfangled pumps could spew out an impressive 60 gallons of water per minute, about what you get from 2 garden hoses. The first horse-drawn fire trucks with steam-powered pumps went into service in 1852. Gas-powered trucks replaced them in the early 1900s. This pumper truck can deliver 6,000 liters of water per minute. Mechanical engineers usually custom design fire trucks to suit the particular needs of the fire department placing the order. The truck's body is made entirely from 4-millimeter thick sheets of marine-grade aluminum. Following the technical drawings, workers cut the aluminum panels to the sizes required, notching certain corners at a 90-degree angle. Workers weld the pieces together to form what's known as the crew cab. The crew cab not only carries the firefighters, it also houses the control panel for the water system. Meanwhile, other workers measure and then cut pieces of aluminum to build the subframe that will support the crew cab from underneath. They weld the parts together. Installing the steps, workers leave a gap of about 1.5 centimeters to enable water to drain down. They line the storage compartments with aluminum sheets, using a sander to make textured circles on the smooth surface. This pattern will camouflage the scratches that moving equipment in and out will inevitably create. They use a machine called a press brake to bend the sheets to the required shape. Then, using what's known as a punch press, they cut holes for the built-in lights, the door handles, and the various control knobs. Workers now assemble the pieces and make any necessary adjustments before painting rather than after to avoid damaging the finish. After this fine-tuning, they'll disassemble everything and send the parts to the paint department. After that, they'll put it all carefully back together. The full-scale assembly can now begin, starting with the water pump. It arrives here ready-made from the supplier. Next comes the crew cab. This one isn't for the pumper, but rather for a yellow rescue vehicle. The pipes that lead to and from the water pump go into a threading machine. The pipes are part galvanized steel, part stainless steel. Once they're threaded, they're ready to be screwed into the pump's water outlets. The drive shaft, that long piece coming from the transmission, doesn't just perform its usual job of turning the rear axle when the truck is in motion, it also powers the water pump when the truck is parked fighting a fire. This control box runs the fire truck's electrical system, including the flashing emergency lights. Each wire is color-coded, number-coded, and function-coded. Workers run the wires from the box to the control panel in the crew cab. Then they hook up the odometer, speedometer, and other dashboard indicators. They install water pressure gauges, adapters for connecting the hoses to the water system, and pressure release valves for adjusting water pressure. Lo and behold, a shiny new fire truck built to a department's exact specifications. Only there's one thing the client didn't have to specify, that it be painted fire engine red. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.
Kinks in assembly put the police bike's NYPD debut in jeopardy. Coming up next on American Chopper. Creative differences generate tension on the Hildebrandt restoration. It's American Hot Rod. Tonight. Scientists know that another massive eruption is due. They just don't know when or where. Supervolcano. Sunday,